was for a radio wave to be transmitted, received by another unit, and sent back. And the other option was to measure power received and then devise a reference in order to determine distance. We chose the counter-based method. We ran into several challenges. First was to find components that operated at the frequencies we needed. Second was working with the transceiver we chose, because it's a low-power device and it switches into standby every time it goes from transmit mode to receive mode or back again. And third, which is kind of still a problem, is actually getting the counter to operate. However, despite all that, we do have a couple of accomplishments. First, we were able to get two of the units to communicate, and we did find components that would operate at the frequencies. Third was we did learn how to use EcoCAD soft in order to design a PCB because the counter did not have an evaluation board we could use in order to create a prototype. But I think the most important thing, well, besides those challenges, we did have some accomplishments, and I think the most important thing that we learned was to read data sheets. We read them, but I don't think we fully understood what they were trying to tell us. And if we would have been a little bit more aware of this and asked more questions of the manufacturers where we got the components, I think we actually might have a working circuit today. Again, so we have the future of this project involves actually getting the counter to operate. Since we've only been able to power it up and either get all zeros or all ones from it to make the counter. We have been able to reset it from its initial startup state, but we think our problem is actually clocking the counter. Second is that we would like to either redesign or find another implementation of the transceiver in order to get rid of the delay that we have with the unit we have now. Third is to redesign the PCB and then do some range testing outside the laboratory. But finally, our goal is to actually have two working prototypes at the end of this next semester to be placed on the UAVs so that we can demonstrate the capability of our device. And we'd like to answer questions if we have any.
What's the expected range that you've been asked to go provide?
Ideally, Mr. Kasling wanted a mile.
Okay.
We think that he said that that's not set in stone. If we can get accuracy so that they can be within a half a meter of each other, that's more important than actually getting them to communicate a mile out.
Okay. Currently, the transceiver we're using is 6.4 gigahertz. What we're looking to is maybe expanding that to 900 megahertz to extend the range.
I'm sorry, is this unit on one or two?
Yes, one zone.
Can I ask, how often did you meet with Kasling aircraft? Weekly, or do you have a mentor that you were interacting with?
We both met with our mentor, Professor Bott, and Mr. Kasling most every week. There were a few weeks that Mr. Kasling couldn't make it, and there was a time one week that we actually went to his offices and saw some of his projects that he's actually working on. So we work with him pretty closely.
From a design standpoint, what kind of calculations were you doing to identify that your solution had the chance of being successful?
Right. Well, we based the calculations on the speed of light, the radio waves traveling at the speed of light, and then determined distance based on, okay, if it was going to take so much time to get it, convert that find another microcontroller that has a little bit more capability than the Arduino that we chose.
We've investigated with the manufacturer of the counter. In this last week, we were told that we need to be aware of an offset voltage that wasn't actually included in the data sheet. And so we believe that there's some jitter in the clock from the DCO that's it's locking up or seizing our counter, giving us an all-one state. And once we can, right now, we can get some equipment that would actually see that scope out that clock, with it being high frequency, we may be able to take out some of that DC component and get it in the range where it wants the clock to generate.
Are there going to be some field testing?
As soon as we get this counter to work, we'd be able to field test today. We have all the components necessary, and actually we've been able to power up all the devices with two 9-volt batteries, on a breadboard that we could walk around with. So if we can get that counter to operate, we could do range testing today.
You know, an 8-bit binary counter seems awful light. I mean, that's sort of 56.
Well, we can actually stage that counter to 16-bit. We wanted to try and our initial